Alright, if you guys could please look at 2.2, Analyze Conditional Statements. We're going to go over some vocab first. A conditional statement. A conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. Conditional statements typically come in if-then form. Okay, basically, if I were to say, if it is raining, then the ground is wet. That is a conditional statement in if-then form. The hypothesis, once again, is the if part of the conditional statement, and the conclusion is the then part. It's important to note that the hypothesis is usually labeled with a P, and the conclusion is usually labeled with a Q. So for example, this is the sentence I gave you guys before. If it is raining, then the ground is wet. This is your hypothesis. This is your conclusion. Okay? So the part that comes after the if, that's your hypothesis. The part that comes after the then is your conclusion. A negation is basically the opposite of a statement. Okay? The negation of a particular statement is usually labeled with this little squiggly in front of it. I'll give an example of what that looks like. Alright, the converse. If the if-then form of a conditional statement is the hypothesis and then the conclusion, the converse is just the reverse of that. Q implies P, the conclusion, and then the hypothesis. Okay, so for example, if the original statement was, if it is raining then the ground is wet, that's P implies Q. Q implies P would be, if the ground is wet, then it is raining. So you just switch the P and the Q. The inverse is the negation of the hypothesis implies the negation of the conclusion. Okay? So for example, the original statement, if it is raining then the ground is wet, not P implies not Q is, if it is not raining, then the ground is not wet. Okay? Alright. The contrapositive is basically the inverse of the converse. It's not Q implies not P. Alright, so you basically switch the P and the Q and you negate them both. So, the original statement, if it is raining then the ground is wet. If the ground is not wet, then it is not raining. That would be the contrapositive. Alright, equivalent statements. Equivalent statements are basically two statements that are either both true or both false. Okay? Now, something to keep in mind, the conditional statement will always be equivalent to its contrapositive. So P implies Q is equivalent to not Q implies not P. If this statement is true, then this statement is also going to be true. And vice versa. If this statement is true, this one will also be true. And if they're false, then they're both false. The converse will always be equivalent to the inverse. If they're both true, if this one's true, then this other one also has to be true. If this one's false, then this one is also false. Alright, two more. Perpendicular lines are two lines that intersect to form a right angle, a 90-degree angle. And last but not least, a biconditional statement is a statement that contains the phrase if and only if. By the way, just a reminder, this little symbol means angle. Okay, let me write out the definition. Okay, so in the case of a biconditional statement, P implies Q and Q implies P. The phrase if and only if, from here on out, I'm going to abbreviate it with IFF. If you see IFF, just think if and only if. So, an example of a biconditional statement would be, it is raining if and only if the ground is wet. That would be our original statement in biconditional form. Okay? Alright, let's go on to page 2. Rewrite the conditional statement in if-then form. All vertebrates have a backbone. Okay, first we have to identify the hypothesis and the conclusion. So, all vertebrates have a backbone. So if an animal is a vertebrate, then it has a backbone. I'll let you guys figure out these two. Okay, write the if-then form, the converse, the inverse, and the contrapositive of the conditional statements Olympians are athletes. Then decide whether each statement is true or false. Okay, so if-then form, if you are an Olympian, then you are an athlete. And this is true. Olympians are athletes. Oops. The converse of this would be, if you are an athlete, then you are an Olympian. This is false. Not all athletes are Olympians. Okay? The inverse would be, if you are not an Olympian, then you are not an athlete. This is also false. You can be an athlete and not be an Olympian. The contrapositive, if you are not an athlete, then you are not an Olympian. Oops. This one's true. If you're not an athlete, then definitely you can't be an Olympian. Okay? So, this is my P implies Q. This was P. This was Q. This here was Q implies P. I just switched them. This was not P implies not Q. And this was not Q implies not P. I want you guys to notice that these two were both true, and these two were both false. That's because the conditional and the contrapositive are equivalent. If this one is true, then you know this one also has to be true. If this one's true, you know this one has to be true. And the same thing if they're false. These two, same thing. They're equivalent. If one's false, then the other one has to be false also. Alright, let's go on to page 3. Perpendicular lines. If two lines intersect to form a right angle, then they are perpendicular lines. The definition can also be written using the converse. If any two lines are perpendicular lines, then they intersect to form a right angle. Okay, so line L is perpendicular to line M. This little symbol here means perpendicular. Okay, I'll put that up here. Decide whether each statement about the diagram is true. Explain your answer using the definitions you have learned. AC is perpendicular to BD. AC and BD, they intersect to form a right angle. So the statement is true. The right angle symbol indicates that the lines intersect to form a right angle. So you can say the lines are perpendicular. Angle AED and angle BEC are a linear pair. AED and BEC that's this angle and this angle, form a linear pair. This statement is false. Because these angles are not adjacent angles, remember adjacent means they share a side, they're attached. Angle AED and angle BEC are not a linear pair. Alright, write a biconditional. If two lines lie in the same plane and do not intersect, then they are parallel. Here's my P. Here's my Q. So the converse would be if two lines are parallel. This is my symbol for parallel. Okay? Then they lie in the same plane and do not intersect. Now notice that this statement and this statement are both true because, I forgot the Q over here, because they are both true, we can write this as a biconditional statement. Two lines, oops, are parallel if and only if they lie in the same plane and do not intersect. Alright, let's go on to page 4. Okay, we have a couple checkpoint problems here. You guys can do these on your own. And that's it for today. Okay, I'll see you guys tomorrow.